Hi, mathematicians. We are going to summarize everything we've done in Unit 1 so that after this video, you will be able to identify 4 functions, the linear, quadratic, exponential, and absolute value from a table. Find this page in the front of your binder. Remember, we're calling these our anchor notes, and we are going to add some details today. You might want to put a flag on these so you can refer to them easily on the table. You have already completed the summary pages for all of our linear on the next 2 pages, but I'll just quickly highlight that the rate of change must be constant for linear functions. You may not have this on this page. You could add this unit rate is equivalent to the rate of change, but must be simplified to something over 1. You can see our constant rate of change right here, negative 10 over 1. Those are all the same, so it is constant. This page should already be filled in from a previous video, but feel free to pause if you need to fill this in. Remember, Table A is like Lesson 2, Table B is like Lesson 3, and Table C is like Lesson 5. On our quadratic page, you have this filled out again from a previous video. Let's talk about rate of change. We'll zoom in on the bottom part of your page. So always when we're looking at rate of change or identifying a function from a table, we need to look at the change in y over the change in x. You'll be only filling those in for the values that are listed. I put some placeholders here that we will fill in later as we complete our table. So we can see that our change in x is constant. Each x value is increasing by 1. My y values for this quadratic table are changing. The change in y are changing. So that means we're going to need to find the second difference. From 10 to 6, I am decreasing, and I'm decreasing by 4. From 6 to 2, I am decreasing by 4. From 2 to negative 2, still decreasing by 4. We know that all of these will be decreasing by 4 because at the top of the page we know we're doing a quadratic example. But if you didn't, you're just doing a table, you would find each of those values. You're checking those here. These second differences help us fill in the change in y. So now I can say negative 6 minus 4 gives me negative 10. So negative 10 should go inside that box right there. Negative 10 minus 4 is negative 14, and negative 14 minus 4 is negative 18. And we can use that value, those values, to help figure out my table. So 34 minus 10 is 24. 24 minus 14 is 10. And 10 minus 18 is negative 8. Let's take a quick minute to recognize the pattern. So our vertex, which you can find before we even find our values, but we can see here there was our change in direction from increasing in our change in y to decreasing, and that points right at our vertex, which is the other way of seeing this. We also see that 40 and 40, 34 and 34, and 24 and 24 all buddy up. And if our table kept going up, we would have partners for our 10 and negative 8 as well. But that's another way to use our pattern. We did 34 minus 10 to get 24, but we could have known that it was 24 because this 24 at the top. So use that pattern when you're filling in your tables. For our rate of change, we know that our rate of change is many. We have all of these would be different rates of change. So 10 over 1, 6 over 1, 2 over 1, negative 2 over 1. But we know that our rate of change is decreasing by the same amount, or changing by the same amount, which is negative 4. So you will write, whenever I'm asking you for the rate of change and it's quadratic, you're going to say that the rate of change is, in this case, decreasing. by 4 because of this second difference right here. For any quadratic table, to describe your rate of change, you're going to say the rate of change is increasing or decreasing by whatever your second difference is. And if your second difference is negative, then you know you're going to be decreasing by that value, by the number part. So that's why this one was our rate of change is decreasing by 4, because I have this negative 4 right here. When looking at why our table is a quadratic table, if it has a vertex, a turning point, and not a constant rate of change, but the second difference is constant, then we know that it is a quadratic function. And I've summarized that right here. So looking at your exponential page, all of this should be filled in from a previous video. Let's focus in on our tables and rate of change. So I'm going to zoom in. This would be the bottom half of your page. Always the first thing you're going to do is the change in x and change in y. So we can see our change in x. Each are increasing by 1. Our change in y are increasing by various amounts. Now we know this is exponential, but if we didn't know that, we saw that it was different, we would take the second difference first and we'd see that this is 400, this is 1200, this is much bigger. And so we would then look for a common factor, a common multiplier or divisor. And so let's do that now. 200 to 600 is getting bigger, and you can think of that as just 2 to 6, or you can divide it out on your calculator. But 200 times 3 gives me 600, and we're going to check to see if that's the same. 600 times 3 also gives me 1800. So pretty confident that that is our factor, and we know that that should be what these two other values are. Now I can fill those in because 1800 times 3 is going to give me 5400. And then if I take that 5400 and multiply by 3, gives me 16,200. And these are both positive, so I can use those. So 2,700 plus 5,400 gives me 8,100, and 8,100 plus 16,200 gives me 24,300. So 24,300. So remember, when we're talking about rate of change, we're talking about how the change is happening. Since our rate of change is not constant, we have all these different rates of change. We're going to say that our rate of change, in this case, is increasing by a factor of 3. So for any exponential function, when you're talking about the rate of change, when you're being asked about the rate of change, you're going to say the rate of change is either increasing or decreasing by a factor of whatever your common multiplier is. And if you're multiplying, then you know it's increasing. If it happens to be dividing, then you're going to be decreasing. When we're looking at key characteristics of a table that let us know that it's exponential, we are looking that there is no turning point. That means it's either always increasing or always decreasing, that it is not constant. So when we do our change in y and our change in x, that they are not constant. And the increase or decrease happens quickly. So we're starting slow, but then look at how fast we're getting into the thousands and the 10,000s down here. Looking at our absolute value page, again, this is filled in from a previous video. We're going to talk about tables and rates of change. So I'm going to zoom in to the lower half of your page. So again, always start with our change in x and our change in y. So looking at our table, our change in x is increasing by 1 from each of these values, and our change in y is decreasing by 15 and then increasing by 15. And we can expect that pattern to continue. So we see we have a turning point, and we see we have two sections of a constant rate of change. And they're opposite. So I have negative 15 to positive 15. So we know that this should also be increasing by 15. To fill in the rest of our values, we're going to take a 335 and add 15 to that to get 350. And then 350 plus 15 gives us 365. To talk about our rate of change, it is going to be the change in y over the change in x. And it's always going to be plus or minus, plus and minus for absolute value. You're going to have opposites. So in this case, we have plus and minus 15 over 1. And it is already reduced to the unit rate. So in talking about key characteristics of our table, it's always going to have a vertex, and it's going to have two opposite rates of change. So we have negative 15 going to positive 15. That is just to say that there's a change, that rate of change changes from increasing to decreasing, or vice versa. So this summary page is not in your notes. You're welcome to take notes for yourself if you think this would be helpful, or just listen and get an overview. But a linear function means the change in y over the change in x is always going to be constant. Absolute value, our v shape, means the change in y over change in x changes from positive to negative or negative positive, that you're going to see opposites. An exponential function, which is that lazy L shape, it means the change in x is constant and the change in y is not constant, which means you need to look for a common multiplier. So it means change in y is multiplied or divided by a factor. And then quadratics, which is our U-shaped graph, the change in x is going to be constant, the change in y is not constant, and the second difference is constant.